Thanks for having us. Thank you, Matt, for hosting us tonight. My name is Sam Kassoumeh. I'm a co-founder and COO of SecurityScorecard. With me tonight, joining me is Dr. Bob Sohval, who is our director and heads up our data science department at Scorecard. We're a security rating services company based here in the heart of Manhattan. Thank you. So we're talking tonight about cybersecurity data at scale. What exactly does that mean? At Scorecard, we use our data to tell a story. We tell a story about companies' behaviors and awareness as it relates to information security best practices. And the stories that we tell are temporal. They're over a period of time. We look at past history of companies' behavior and security health. We also look at current state. And we fuse those two things together to help us sort of predict, to peer into the future and get a sense of a likelihood that some type of future bad thing could occur, like a breach incident or some type of emerging threat, like a WannaCry or struts. Now, before we talk about the what and the how, I'm going to double click and just explain a little bit more about the why. Why do we do what we do? Because talking about security is really, really hard. And if you've never experienced this, I would recommend everybody go ask 5 colleagues in 5 different departments one question: how secure are we? Seemingly innocent question, but a very, very complex and in-depth answer. And as a former chief security officer myself, I got asked this question all the time. And what you're going to notice in the responses is they're all different. It's going to sound, you're going to get sort of different responses from technical to visionary. You're going to notice one constant. It sounds like everybody's speaking a different language. And that's always how I felt when I would talk about security. It's kind of like, it's like going to Chipotle and ordering your favorite burrito bowl, but having to explain your order in English and German and Swahili or something every single time that you order the food. It's very difficult. So again, why do we apply data science to security? Because it helps us to create this vocabulary of risk. It's a common language that enables us to have practical conversations across the entire organization, whether you're a security practitioner or engineer, or you sit on the board or the audit committee, to discuss risk, to understand risk, essentially leveling the playing field and removing some of the emotion and replacing it with data-driven decisions. And these decisions allow us to de-risk our own companies, other organizations, the ecosystem, and also ensure that we get a high return on security investment. For a little bit of context, where do we get the data? The data comes from all over the place. We collect data from the public internet, entire IPv4 space, as well as the deep web and dark web. And we're collecting terabytes and terabytes of this information every month in a very automated fashion and a non-invasive, non-intrusive fashion, using both active and passive collection techniques. This data is then processed. We analyze and benchmark the data. We look at how a company's been performing over a period of time, and we compare companies' performance against their peers and also their competitors of similar size within the same industry and the market. And by performing steps 1 and 2, it helps us to tell the story. And we view data science at SecurityScorecard as the connective tissue, or the fascia for those of you that are biology majors, that help to hold together and also mend together the observations into the stories that we tell. And with that being said, I'm going to turn it over to Bob to talk about the how.
Thank you, Sam. Oop, wrong way. So let's just get a quick picture of scale. Currently, we monitor in the vicinity of some 200,000 entities, mostly companies, but also government organizations, government agencies, hospitals, different organizations. We plan on growing that to about 1 million by the end of next year. We're ingesting some 7 terabytes of data right now. That will grow a factor of 6 at least next year. And by the end of next year, we'll be at the petabyte level. So here is a picture of our data flow. I was just looking for color because the color doesn't quite match what's on the slide, but that's all right. So this will give you a sense of what we're doing. We have entities, as I say, some 200,000 entities in platform right now, and each of them has a set of digital assets, domains, IPs, maybe autonomous system numbers and so forth, security certificates. Many of the, let's say, defects in security that we're able to surface are IP related. So an important task that we have is to associate or attribute a given IP to a given entity, as well as domains and related domains and so forth. So that's an attribution process. We then make our raw observations, and then we have a bank of analytics that process those observations and produce security issues, such as ports that are open and exposing services that should not be exposed, malware. We operate our own bank of sinkholes and honeypots to detect malware on systems that are on the companies that we monitor, expired security certificates and the like. And from the security issues that we're able to observe and manifest, we then generate a score. And we use a grade school rubric, A, B, C, D, F, just because it's easy to communicate. Now, I can't quite tell because I'm a little bit colorblind, but this is supposed to be gray, and that's supposed to be gray, and that's supposed to be gray in between. And I mention that because that's where data science sits in the company. And I think gray, even though it may not come out so well in a slide, is an appropriate color choice because we generally don't deal with black and white. We do a lot of fuzzy math. There's something in between, a lot of probabilistic decisions and so forth. So what is the role of data science at the company? A primary one is one that I mentioned, IP attribution. There are tons of subtleties here. I'll start with related domains and subdomains. You might have bankofamerica.com, but there might also be bankofamerica.nyc.com or BOA.com or something like that, all of which are properties and may have security issues associated with them. So we need to make a proper attribution. A very challenging problem that we're working on is to distinguish between corporate IPs and leased IPs. For example, take Verizon. Verizon may have some IPs that are used in their corporate headquarters, but many of their IPs are made available to residential customers. They're leased IPs. And you don't want to take a defect or a security flaw from somebody's residential use of an IP and misassign that to Verizon. Analytics, I've mentioned one of our initiatives is around organizational health. Do we see security issues and the handling of security issues at the enterprise getting better over time, getting worse? What is the trend? Scoring, that A, B, C, D, F, and numeric scores behind that. It's non-trivial because we're measuring basically a risk-based attack surface. But momandpop.com is going to have a very different order of magnitude attack surface than Amazon or Microsoft.com or something of that sort. In terms of digital footprint, number of IPs, that spans more than 8 orders of magnitude. So we've developed what we call a normed-based scoring system that does a meaningful job of assigning those scores. And I would say the holy grail is breach prediction. This is a challenge where our clients are interested in what are their prospects for breach, but we also look at and provide information on that our users' ecosystem of vendors. A given entity might have 1,000, 5,000 vendors that they do business with, and they are as strong as as is their portfolio. So let me give you just an example of something we're looking at right now in terms of organizational health. This is insecure browsers. We've developed a crowdsourcing technique that can identify the latest or current version of browsers. And what you're looking at here is horizontally, it's a time axis over a 90-day period. And this is the fraction of browser activity that is being performed with up-to-date or out-of-date browsers. So red is indicating out of date, green would be the portion that is up to date. And Northwestern Mutual on the left is doing a pretty reasonable job of keeping their browser use up to date. Experian, not so much. And this is a signal that they're not paying enough attention to security hygiene in their company. We can also dig down a little bit deeper and show and display browser families. So what we're looking at now is granularized to reveal Safari, Firefox, Edge, Chrome, and so forth. Obviously, we could make a pie chart to show what is the distribution of usage of browsers. And this may be a surprise to a chief security officer who may have a policy in place that you're only allowed to use Edge or only allowed to use Firefox or something like that. Guess what? Surprise. That's not the case. So breach prediction is the holy grail, I would say. But it is a hard problem. As Sam mentioned, we work on outside-in observations. We do not have sensors internal to a company's networks. We don't do any penetration testing or anything of that sort. It's totally non-intrusive. But there are a number of challenges that we face in data science in terms of making breach prediction. One is that there's a huge class imbalance. The number of non-breach companies, the ratio of non-breach to breached is something like, in our system or our platform, something like 1,000 to 1. So it's a little bit of a needle in a haystack kind of problem. That is soluble by upscaling and downscaling, but it's something that we have to be concerned with. A bigger problem is that breaches generally are underreported or widely believed to be underreported. So we can only work with publicly disclosed breaches. But you can imagine if you've had a breach and if you are not obligated under regulatory requirements to report that breach, you may not want to embarrass your CEO or your board of directors and so forth. So breaches are underreported, which causes a data science problem because that means when we're doing supervised learning to train an analytic, some of the data are going to be mislabeled. Right? Some of what we believe are not breached companies actually were breached. Another problem is timing. As Sam mentioned, we do both static snapshots and we watch over time how companies are handling their security issues. Are they remediating them and so forth? Well, we would like to know what was the security picture at the time of breach, but we don't really generally know the time of breach. There's the date that a breach actually occurs. Sometime after that, it's detected. Industry average is 5 months. Some organizations are better. Some, DNC, for example, it took them over a year to find out that they were breached. It'd take longer. Then from the time of detection, there's another time lag until the breach is reported. And the report date is what is available publicly. So there's some fuzziness, if you will, surrounding the actual dates. And I would say that in general, breach prediction on portfolios is somewhat easier than for individual entities. The law of large numbers does apply here, and it's easier to make statements at a portfolio level. But we can make some statements. So what we do is, one thing we can do is segment our data in terms of those entities with good scores versus bad scores. Good scores would be A's or B's, bad scores C, D, F. And this is just a simple Bayesian statement of the probability of a breach conditioned on a poor score. And what we don't know is that we don't know the prior probability of a breach. We just don't know. But we can construct a likelihood ratio of the probability of a breach given a poor score versus a good score. And we look at our data, and that is a ratio of 5, something like that. So poor scores are predictive of breach. And we can put that together into a portfolio risk analytic. On the x-axis on that graph is basically the the risk of what we would call uncorrelated risk. It's basically built on the scores of the underlying assets or underlying companies in a portfolio. Using that ratio of 5 that I just mentioned a moment ago, it's a balance between good scores and poor scores. The vertical axis is correlated risk. We use machine learning to look at security issues, to identify security issues which are common among the portfolio companies. So think about correlated defaults for mortgages or something like that, and are also common among recently occurring breaches. And that gives us what we call a breach multiplier score. And the product of those two gives an indication of the overall risk that a portfolio may face. And so to the upper right is riskier than to the lower bottom. The red markers are portfolios that have had one or more breaches. The blue markers are breachless. And it's a way of visualizing and going a little bit deeper in analyzing a portfolio's risk. And I think we're going to wrap it there. Thank you very much.
Thank you.
Thank you. Join me.
Should we take seats?
Yes, please. I'm trying to rearrange this. Is this on? Cool. Thank you very much. Super interesting. Just one quick question from me. You mentioned you get data from the dark web. How does that work exactly?
Secret. No, I'm just kidding. There's no silver bullet for data collection, whether we're getting it from public web or deep web, dark web. But we do have various techniques that we've built homegrown that allow us to essentially crawl on things like hacker forums and vacuum in signals of risk. Like if a company is being discussed on a deep web forum, we vacuum in that data, and then we analyze in what context is that company being discussed. When a company's user credentials are being traded, it's treated as a different severity versus somebody on a forum saying, hey, who wants to hack Target with me?
It's very interesting. I hadn't realized that you guys had no inside data from the company. That's fascinating. Okay. All right, I want to open up to questions.
Yeah. So I hope, at least by the nature of the things that you're looking for, these are outliers, right? So how many examples in your daily analysis do you see for a certain type of breach so that you can actually do statistics with it?
So typically there are on the order of a couple thousand breaches that are publicly reported each year. There are other types of adverse cyber events, like DDoS attacks. So different types of breaches are reported that include things like stolen laptops, which is not of interest to us. So our primary concern has been a penetration of the organization from a malicious actor from the outside. DDoS is something that we will probably look at. We track malware. Ransomware is a growing business. We don't currently separate for ransomware, but it's something that we'll probably look more at in the future.
Wait, hold on. Just more questions. Just one over there. Or just one question. Hold on. There's a microphone.
Thanks. Hi. Thank you. Can you identify a breach based on your data collection and anticipate it before it's happened or been publicly announced?
This is what we're trying to do. It's, as I was explaining in my slides, it's not an easy problem. We can make, it's easier to make predictions at a portfolio level than it is at an individual level. The best statement that we can make right now is that if you have a poor grade on our platform, poor total grade, your chances of a breach are increased by a factor of 5 compared to if you have a good grade. We are working right now on stronger predictive analytics, but that is the statement that we can currently make.
Good. One last question over there.
Yeah.
Hold on, the microphone is being passed on to you.
Could you explain why portfolio level is easier to identify?
What I'm saying is that, what I mean by that is that it is easier to predict risk over a portfolio or an ensemble of entities than what the behavior will be than for a single entity. It's just things gravitating toward the mean is what I mean by that. Aggregate, yes.
A lot of companies are super interested in the aggregate. Imagine, for example, cyber liability insurance underwriter underwriting, $50 million worth of hacker insurance. They don't so much care if one company gets breached, they'll just kind of take it to court. But if there's some type of systemic event that's going to cause 90% of your portfolio of insureds to be kind of flooded and everybody's going to come to you and make a claim, like, you would be very worried. Same thing for most corporations. They have thousands, sometimes tens of thousands of supply chain vendors, partners with whom they're doing business with, exchanging data with, and they have no idea where the kind of breach likelihood lives.
Jerome gets a question since he's one of the
Okay,
speakers.
I have the unfair question of the night. What was Equifax rating before the breach?
It was in the middle. It was in the B-C range.
And we unpack those letter grades across various factors,
Yes.
application security, network security. Bob talked about the 5.4x likelihood. If we see a grade of C or lower across patching cadence, is it patching cadence specifically? Doesn't it jump up to?
So there are underlying factors or categories like network security, malware, IP reputation, which is really malware and so forth. Some of those categories are more predictive, meaning they have a higher multiple than 5 for being predictive of breach. And most of those are kind of around social aspects. How good a job am I doing at repairing or patching known defects? How good a job am I doing at preventing passwords from being leaked into the wild and so forth? There's a very common theme of human interaction.
All right, gentlemen, that's all the time we have. Thank you very much.
Great.
Thank you.
Thank you.